Alright, let's go over the first question. The magnitude of an earthquake measured on the Richter scale is log of I over I0 base 10, where I is the amplitude and I0 is the amplitude of a certain small size. Find the Richter scale rating for an amplitude of 100 million I0. So all we need to do, use the formula. So we have the log I over I0, and this is base 10. Since I is given to be 100 million, which is 10 to the power 8, I0 over I0, so these will cancel, and then we can move the 8 over here, so this would be 8 log of 10 base 10. Log of 10 base 10 goes to 1, and therefore this would be 8. So the R would be 8 for the first. Again, this is, if you count, 1, 2, 3, 4, 5, 6, 7, 8. That's 10 to the power 8. And we use the power rule to move the 8 as the coefficient. And this would be log 10 over base 10, and that would be 8. Okay, let's try number 2. On number 2, we have to find the equation, give the exact solution. So, okay, so we want to find the equation in terms of log. So again, we use the formula a to the y equals x is equivalent to y equals log of x base a. Here we have 5 to the x, so this is 5 to the x equals 17. Notice that the base is 5, so this would be log base 5. The exponent is x, but the exponent here is y, so x equals, and then this x here, 17 is x, so this x is 17. And that should be the final answer. Let me see which one will match this one. Log of 17 base 5. This is log of 17 base 5. So A, because look, if you use the change of base, x would be log 17 over log 5. So these are exactly the same, except we are changing the base from base 5 to base 10. So A would be the answer. Let's go to number 3. Solve the equation, and this is another exponential equation, and we notice that since we don't have the same base, then we have to use the logs. So let's take logs on both sides. That would be log of 5 to the x minus 3 equals log of 3 to the 2x, and I use base 10. You can use any log, any base. I use base 10. So again, 5 to the x minus 3 and then log of 3. Since we can use the power rule to move this here, so we're going to have x minus 3 log 5 equals 2x log 3. So we're going to have x log 5 minus 3 log 5 equals 2x log 3. We want to move the x, so this is like a linear equation. So I want to skip a step here. I want to move this 2x log 3 to the left and then take x as a common factor. So that would be x into log 5 minus 2 log 3. And then I move this to the right, 3 log 5, and then divide both sides. So x would be 3 log 5 divided by log 5 minus 2 log 3. Let me see, I don't know how simple they want, round to the nearest thousands. Oh, they want us to find this answer in decimal notation. Okay, so we can find this answer in a decimal notation. So let me see if I can simplify it a little bit. Log 5 over, so you notice this is to the power 2 to the power 3. I can move the 2 back here, and that would be log 5 minus 3 squared, which is log 5 over 9. So that would be log 5 over 9. And of course, we have a base 10. So I move the 2 to the exponent. That would be 3 squared. Subtraction, I use the quotient rule. So all I need to do is divide 3 log 5 by log 5 over 9. Let me see if I can do this on this calculator here. So that's going to be parentheses 3 log 5 close parentheses divided by log 5 over 9 close parentheses. Okay, this doesn't work. Let me see if I can fix it here. So this is going to be divided by log, let's put this inside parentheses, 5 over 9. Okay, this looks much better. And let's see what the answer is. Okay, so the answer is, let me find out here. Okay, so that's going to be 8 minus 8.2143. Let me see how do they want us to submit the answer to the nearest thousands. Okay, so to the nearest thousands, this would be minus 2.664. So negative 2.664. Okay, let me make sure I did this right again. So 3 log 5 over log 5 over 9. And then in the calculator it is okay, so I had the wrong answer. So this would be minus 8.2144. 8.214, since this is the nearest thousands. So 3-digit after decimal, 2.14. So let me try to put this again. Okay, that should work. That should be the right answer. 8214. No need to round because this is 3. All right, let's try the next question now. So the next question would be number 4. And to find the log, we just change it to exponential. 6 to the power 4 equals 5x minus 4. Let's go ahead and do this one. So we have 6 to the power 4 equals 5x minus 4. Add 4 to both sides, then 5x would be 6 to the power 4 plus 4. And x would be 6 to the power 4 plus 4 over 5. Okay? So again, to change log to exponential, 6 to the power 4 equals 5x minus 4. And then we add 4 to both sides. So you have 5x is 6 to the power 4 plus 4. Then divide both sides by 5. And let's try to use this calculator again. So 6 to the power 4 plus 4, 1,300. So this is 1,300 divided by 5, and that's 2. 30 by 5, 6, 260. So the solution set would be 260. Let's check. Let's see if we get the same answer. 5 times 260 minus 4, and that would be base 6. So if I do this on the calculator to check, so we have log of 5 times 260. Okay, let me try again. Log 5 times 260 minus 4, and this is divided by log 6. So I change this to a base 10, see if I get the same answer. And I should get 4, and I got 4, so that's right. All right, let's try number 5. Let's solve. So addition is multiplication, so let's do the multiplication here. multiplication, and that would be log of x times x minus 15 equals 2, and this is base 10, so 10 to the power 2 equals all this. So x squared minus 15x equals 10 to the power 2, which is 100. So now we have x squared minus 15x minus 100 equals 0. Then we need to factor and solve. So again, we did x times x minus 15 because this is addition changed to product equals 2. The base is 10. 10 to the power 2 is 100, is x squared minus 15x. Move everything to one side. Let's try to factor. We want the product to be 100 and the sum to be 15. So 10 times 10 is not going to work. 25 times 4 will not work. So what else we can get the 100? 50 times 2 will not work. Simplify your answer. Use comma to separate. Simplify your answer. Type an integer or a decimal. So maybe we should use the quadratic formula because I don't think I can do this. 25 times 4, 20. Oh, 20 times 5. Oh, that's the one. Okay, 20 and 5. So 20 times 5 is 100, but 20 minus 5 is 15. So we need a negative for 15. So this would be negative. This would be positive. So as you see, the product is negative 100. The outer is 5x minus 20. And so x would be negative 5 or x equal 20. X cannot be negative 5 because x should be greater than 0. But x can be 20, so 20 would be the final answer. Number 6. Again, let's solve for a logarithmic function. This is a base e, natural log. So again, this is division. So that would be natural log 5x plus 14 divided by x. So this is the quotient rule equals natural log of 6. Log equals log, the same base, so the inside should be equal. So we have 5x plus 14 over x equals 6. Cross multiply. This implies 5x plus 14 equals 6x. Now subtract 5x from both sides and we'll be done. So x equals 14, so that would be 14 is okay here, it's okay here. So 14 is the final answer. So again, all we did, we used the quotient rule, 5x plus 14 over x under the same log. If a log equals to log, then the inside should be equal. So 5x plus 14 over x equals 6, cross multiply. So x equals 14. Okay, let's go to number 7. An employee wants to invest 60,000 in a pension. One investment offers 6% compounded semi-annually. So to invest, that would be your initial or the principal. So A would be 60,000 times 1 plus the rate is 6%, 0.06 over semi-annually, 2 times a year. And so this is 2 times number of years. So wants to 60,000, one investment over 6% compounded semi-annually after another 5.25% compounded continuously. So we want to invest for 6 years, so this would be 6. So the formula is the P, which is the principal, 1 plus the rate over N, the number of time compounded per year, that's 2 times, and NT, 2 times 6 years. So that would be A. And the other A would be also the principal times e to the power RT, where R is 0.0525 times 6. So you have to do both of these. Let me see if I can do this on this calculator here. So for the first one, I'm going to have to multiply 60,000 times 1 plus, so the first rate is 0.06, 0.06 semi-annually divided by 2, to the power we have 2 times 6, 12, So that would be the first one. It would be 85,545. So here, after 6 years, which one will earn more? Okay, so the first one, this one is 85,545.6. Let's see this one. This one would be 60,000. 60,000 times e to the power RT, which is 0.0525 times 6. Enter. So the other one would be 82,000. So this would be 82,215.5. So this is more. This will give me more. Okay. So the answer would be, after 6 years, the 6% did better. And the better plan will earn how much more dollars? We're going to subtract. So let's subtract. So this is the one that we got with the Alright, let me see if I can do this. Okay, this is 1 minus the decimal here. And the answer is 3,330. So let's just put, they don't specify, 330. The better plan will earn 3,330 more. 3,330 more. Okay, I hope this is right. I like to go over my work and make sure this is, so we have, this is our, okay. All right, we'll see at the end if we missed any one of these. Let's go to the next one, number 8. So we have out-of-pocket spending in a country for healthcare increased between 2002 and 2007. We have a function modeled average annual average expenditure per household. In this model, X represents the year where X equals 0 corresponds to 2002. Okay. Estimate out-of-pocket household spending on healthcare 2007. So 2007, if X equals 0 to 2002, then 7 minus 2 is 5, then X would be 5. So all we have to do, substitute X equals 5. Let's see if we can do this. So let's use the calculator. So here we have 573 times e to the power. We have a 0.0359 times, again, 2007 corresponds to 5 years, 5, and that's it. So let me make sure we did this right, 2007, okay. So the total expenditure per household in the year 2007 approximately equal to, let's see if I can figure out this. So that would be 3,078.9 to the nearest dollar. 3,078.9 to the nearest dollar, 3,079. During the year, spending reached 2008-04 per household. So now we have to use this and then solve for X. So let's do that. Okay, so we have 2,000. Okay, let's try again. Okay, let's open another paint. What's the other one? Here's this one. Okay, this looks better. All right, so we have to solve for 2804 equals 2573 e to the power 0.0359 0.0359x. Let's solve for x. Divide both sides by 2573. And therefore, e to the power 0.0359x equals 2804 over 2573. Change this to log. Remember, a to the y equals x. Therefore, y equals, this is 1, this is y, natural log of 2804 over 2573, and then we divide both sides by 0.359. So that should be the final answer, 2804, 2573. Here we go. Let's try the calculator. So here we have to go with natural log of 2804 divided by 2573. And then again, to isolate x here, we have to divide both sides by 0.359. So let's go ahead and divide 0.0359. Do we have an O, or there is no? There is no O. Okay. So let's take away this 0.359. So that would be x. Let's go find x now. Okay. 0.239. Okay, that's not good. Let's try to do this again. So we need to find x. Spending reached 2,804. Okay, so 2,804 equals 2,573.0. So I missed the O here. So we have a 0 here. Okay, let's do it again. So we have natural log of 2804 divided by 2573, and this is divided by 0.0359. Enter. Okay, that should be better. 2.39. Okay, let's see how we're going to round this. 2.39. Round down to the nearest year. Down. Okay, round down. So 2.39, we're going to call it 2. And so x equals 0 to 2002 plus 2 would be 2004 during the year 2004. All right. Let's do number 9. Oh, that's easy. Let's do the solving the system. So here, if you notice, if I multiply, okay, so this is 2y. Let's multiply here by 2, then we have minus 2y plus 2y. Okay, so 2 times 4, 8x, 2 times negative y, negative 2y, and 2 times negative 10, negative 20. Let me put it in the same order. Okay, so 8x minus 2y, and here we have minus x plus 2y equals 13. Let's add. These will cancel. So 8x minus x is 7x. Negative 20 plus 13 is negative 7. Therefore, x equals negative 1. And then we have to substitute. So 2y minus negative 1 equals 13. This is plus 1. 2y plus 1 to the other side becomes negative 12. And therefore y equals 6. So negative 1, 6 is the answer. Ordered pair. Negative 1, 6. That's it. And of course we have to put ordered pairs. So let's go parentheses. That's important. So you gotta put the parentheses, x and y. X is negative 1. We'll see. Let's check on this first one, see if it works. Negative 4, and then y is 6. Negative 6 is negative 10. Looks good. Next. Again, we have to solve a system. Let's do, okay, we have here 2x, and then we have, let's multiply this by 3, this by 2. Okay, so 3 times 2, 6x. 3 times negative 3, negative 9y. 3 times 30, 90. Second one, multiply by 2 or negative 2 if you want. Negative 6x. Negative 14y. And 47 times 2 would be, times negative 2 would be plus 14 and 9. 94. 2 times 7, 14. 2 times 4, 8. And 1, 9. Okay. Again, it is plus because we're multiplying by negative. Now let's add. So these will cancel. Negative 9 and negative 14. 6 and 3. That would be negative 23y. And here both of them are positive. So 90, 184. Okay. So let's see. 8 times 3, 24. So it's divisible by negative 23, so y would be 184 divided by negative 23. That should be 8. Negative 8 times 3, 24. Negative 2, 16, and 2, 18. So that's a negative 8 for y. Now let's find x. So you have 2x minus 3 times negative 8 equals 30. So this is 24. Move it to the other side. It would be 30 minus 24. That's 6 divided by 2 is 3. So x would be 3, negative 8 would be the solution here. So 3, negative 8. All right, let's see what else we have here. Another 7 problems. Okay, so let's try this one now. We have 48x minus 6y. Oh, I think this everything is divisible by 6. It would make it much simpler. If you divide 48 by 6, it would be 8. 8 times 6, there, 8x. Divide this one by 6, you get negative y. Divide 42 by 6, you get 7. Here you have negative x plus y equals 7. Notice they're exactly the same. So if you multiply here by minus, you get minus, 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 right? Maybe they're not the same. Okay. Let me try again. Okay, so the second one is negative 8 plus y equals 7. And the first one is 8x minus y equals 7. Notice that the slope of this line is minus 8 over negative 1 is 8. And the slope of this line is also 8. And that means these two lines are parallel. These two lines are parallel, okay? If they have the same slope, they are parallel. And you will notice if we try to solve them, there should be no solution. Let's try to solve them. If you add 0, 0, 0 equals 7 or 14, right? We're adding. So that's a no solution. And there is no, so there is one solution. The system has infinitely many solutions. And the solution is an empty set. Okay, since they are parallel, okay, then there is no intersection, there is no solution. If they were overlapping, in case this was, let's say, minus x plus y, if this was minus 7, then these exactly the same line, they would be overlapping, and then we would choose the first option. Otherwise, we will have one solution. All right, let's go to number 12. Okay, this is another 3 by 3. We have to do first two, the last two, and then, okay. If you add the first two, the z will cancel. So 1 plus 2, then you end up with 3x plus 2y, 16 plus 8, 24. But if you add 2 and 3, also the z will cancel. Then you have 3x and the y will cancel. That's a nice. Y and z cancel equals 12. Therefore, x equals 12 over 3, 4. So using x equals 4, substitute in in here, then you can find y, and you're done, okay? Let's substitute x equals 4, so you have 12. 24 minus 12 is 12, divided by 2 is 6, so y is 6. Let's do it again. 3 times 4, 12. Move it to the other side, negative 12. Plus 24 becomes 12. 12 divided by 2 is 6. We still have to find z, so we're going to use the last one. So x minus y plus z equals 4. So this is negative 2 plus z equals 4. Move the negative 2 with by 6, so z is also 6. So the equation, the point of intersection among these three planes, if you want, the line should be 4, 6z. So let's put this. The system has infinitely many solutions. The system has, there is one solution, and the solution is x equals to 4, y equals 6, and z equals 6. I would like you to check, just in case. 4 plus 6, 10. 10 plus 6, 16. 8 plus 6, 14. 14 minus 6, 8. So it applies to all three, so we're good. Let's go to the third one, 13. And here we have a parabola and a straight line, so we're supposed to have, we could have like two solutions. Okay, so x squared, so we can go y equals x squared if you want. And then substitute y for x squared in the second equation. And this is a quadratic equation or a trinomial. We have x squared plus 3x minus 18 equals, the product is negative 18, the sum is 3. So 6 and 3. So that would be plus 6. And x minus 3 equals 0. The reason for that, the product is negative 18 and the sum is plus 3. And therefore x could be either negative 6 or x could be 3. So the solution set is going to be two values here. We're going to find for x equals 6, x equals negative 6, what is y? So for x equals negative 6 squared is 36, y would be 36. So the first one would be, for x equals negative 6, negative 6y would be 36, comma, use radicals, use integers, fractions, express complex number in terms of I, okay, type and order pair, okay. So x equals negative 6, then y would be 36. If x equals 3, y would be 9. So 3, 9. Next, make sure we don't have spaces. No space. Okay, good. And let's see the solution set. Order pair. Okay. So use a comma to separate answers. So we're doing good. So again, this is a parabola and this is a straight line and they intersect at 2 points. Okay, let's go to the next one, number 14. All right, this is another solving a system of nonlinear equations, nonlinear system of equations. Again, we have 8x squared. We have, so let's multiply here by negative 3. Those will cancel. Negative 24x squared. Negative 3 times negative 5 plus 15y squared. And negative 3 is minus 240. Let's do it again. Negative 3 times 8, negative 24x squared. Negative 3 times negative 5 plus 15y squared. And negative 3 times 80, 3 times 8, 240. Here we have 24x squared plus 7y squared equals 240. And if you do the math, these 0 and these are zeros. So 15 plus 7 is 22y squared equals 0, so y equals 0. That's nice. If y equals 0, then 8x squared equals 80. I'm substituting in the first equation. So x squared, 80 over 8 is 10. and x would be plus or minus square root of 10. So here we have two solutions. We have square root of 10. So let's do also order pair. Square root of 10 comma 0 comma minus square root of 10 comma 0 also. So again, here we have like a hyperbola and an ellipse. So like this, hyperbola and ellipse, and they look like they're intersecting at only 2 points here. So if you try to put y equals 0 here, then x squared would be 10, x would be plus or minus square root of 10. So we're doing this, looks like we're doing this good. All right, let's start number 15. Okay, that's one we don't have to, we can just do it right away on the graph. Okay, let me minimize this one. Okay, so here we go. Let's plot this line. For y equals 0, x would be 2. So a straight line with x equals 2. And for x equals 0, y would be 2 over negative 4, negative 0.5. So negative 0.5 should be somewhere here. Oh, I can't do the half. Let me try something else. So for x equals negative 2, then add 2 to both sides would be 4. 4 divided by 4, negative 1. So negative 2, x equals negative 2, y would be negative 1. All right, that's better. And you see it goes through the negative 0.5 here. So if you put x equals 0, negative 0.5, so that's right. Okay, now this is dotted line because we don't have less than or equal. Now we will finish the second line and then we'll find the region. Okay, the second line, y equals 0, x equals 2 over 4, same thing. So let's do y equals negative 2, then x would be 4 over 4, 1. Okay, y equals negative 2, this is the second line. Y equals negative 2, x would be 1. So here's the first point. If y equals negative 2, add 2 to both sides, 4 over 4, 1. Now if x equals 0, y would be 2. So x equals 0, y would be 2. So this is the second point. Now let's find the region. As you see, this is the first line. Let's take 0, 0. 0 plus 0 is less than 2. So for the blue, these are the region on the top. Both regions are good for the first line. Let's take 0, 0 for the second line. 0 plus 0 greater than 2 does not work. So this region is not good. This region is good. So that would be the overlap region here. Let's try again. Again, 0 plus 0 is less than 2 for this line. So the top works because 0 is here. But for the second line, 0 is not greater than 2. So here does not work. It should work here. And here is the overlap. Save. Let's do number 16. Another solution of system. Let's try to see if we can select a tool for, okay. So here, all right, medium. Okay, this is a parabola, so we're going to use, this is the parabola here. And then y equals x squared, x equals 1, y equals 1. So we have a point here. And x equals minus 1, y equals 1, okay? For x equals minus 1 or plus 1, y would be 1. Minus 1, 1. Okay, that's the graph of y equals x squared. Also, it is dotted line, okay? And let's plot this line. For y equals 0, x would be 6 over 3, which is 2. So this is a straight line, and x would be 2. For x equals 0, y would be 6 over negative 2, negative 3. And this is the second one. Okay. So we have the line, which is, again, if x equals 0, y would be negative 3. This is negative 3 for y. For y equals 0, 6 over 3 is 2, the x-intercept and the y-intercept. For the y equals x squared. Now, this is less than x squared. So let's take a point here. Take point 4. And this is 0, 4. So for x equals 0, okay, y is 4. Is 4 less than 0? 4 is not less than 0, so the region should be outside the parabola. You can try another point, 5. Okay, this point is 0, 5. X equals 0, y is 5 less than 0, no. So the region should be outside the parabola. Let's try 0, 0 for the line. Is 0 plus 0 minus 0 less than 6? Yes. So we're looking at this region here, outside. So let's do the between the two. This is the region that is right. So outside the parabola, but above the line, because 0, 0 is a solution for the line. And then one more, number 17. And again, this is another parabola and a straight line. And let's try to do it without calculation. Okay, so how do we plot? This is an x squared. Bring it down 1 unit. Okay, this is the graph of the parabola. It's down 1. And then, of course, it will have 1 point here and 1 point here. Let's see if this is right. Did I do the intercepts right? For y equals 0, x squared minus 1 equals 0, and x minus 1, x plus 1. So x would be either 1 or minus 1, so that's right. Now, for the line, let's plot the line, choose the line option. For y equals 0, x equals 4, so the first intercept is at 4, y equals 0. For x equals 0, y equals 2, so this is the second one. And it looks like both of them are solid line because they're less than or greater than or equal. Okay. So let's take 0, 0 for both of them. Try 0, 0. 0 plus 0 less than 4, true. So for the line, this region is good. 0 is greater than this one is true, so this is the solution. So notice that 0, 0 is true for the line, so this whole region for the line is good. But for the parabola, 0 is 0, the inside of the parabola is good, so this is where they overlap. Save. Let's see if we made a mistake. Okay, we didn't do 7. Oh, we did a mistake. Let's see what the mistake is. Number 7. Okay, so they want us to round to the nearest. Okay, that's okay. Did they say round somewhere? Okay, that's okay. So make sure to round this one to the nearest 1. Okay, good.